So it's kind of like an interesting title because we're talking about real time and then we'll talk about analytics. Usually, historically, analytical stuff that you need to kind of consume or prepare for someone is not happening in real time. You know, we do a business, we collect the data, we run the batch process, and the next day report, our boss will get the report. So with these days, things are changing. And changing in the way that we want to see the data ideally in a time when it happens. If I'm running the small shop that selling pizzas, I want to see, how good we're doing, regardless if I want to wait until the end of the day. And this is actually a dashboard that I put together. You can play around with this like after this presentation. And every component of this dashboard is actually Pinot running behind Pinot running all the queries behind this. And those queries are now we're turning into a world where our analytical queries are not only powering reports, but those analytical queries actually powering the features of our applications. My name is Victor Gamov. I work as head of developer advocacy at a company called StarTree. At StarTree, we're contributing to this open source project called Apache Pinot. We build a managed service on top of Apache Pinot. And today I want to talk a little bit about why Apache Pinot existed and how it came about and what kind of problems we're trying to solve implementing this new cool tool. So I also known as to build very highly scalable and highly available hello world applications, most of the time over-engineered, but for the sake of demonstrations, it is a requirement. So there would be a link for the demo if you want to be hands-on, there's some cool stuff that you can run by yourself. It's always fun to play around with something. Now, when we're talking about analytics, it is a well-known subject. Well-known subject because people have some sort of expectations this. People old enough remember the classical tools like Crystal reports. Maybe some of you build reporting solutions based on some open source technologies like a BERT and so far and so on. And in the world of analytics, I can break this down Barney style in the 4 sections. We have real-time, batch, internal, and external. When we're talking about the classical analytical use cases, we are building dashboards we're building these days. Before that, we're building reports that some of the key figures in the companies need to go and print and deliver at the beginning of the day so the boss will make some decisions. And usually this information needs to be shipped outside. So this information will be required for the people who will run the company in order to make some sort of decisions. There's some changes to some analytical data that people need to use in order to perform or operate business. And the good example of this is observability data. Any type of metrics, any type of traces, any type of logs that we need to collect, this is something that we ideally need to know in real time and make some sort of decisions based on this. Maybe there would be alerts, maybe there would be some sort of notifications. But we're not shipping this information externally. Also, many of you have seen, if you're using any type of service, they have ability to extract some banking statements. So you need to take the batch of transactions that happened over the time and turn them into a nicely formatted PDF so you can use it for your own usage. So that's example of batch analytics and external. And user-facing analytics, this is something that is emerged in the recent years where use cases that some of the businesses want to present to their users would be backed by classical analytical queries. And I'll give you a few examples right now. Also, there's plenty of different tools that support different use cases. And Apache Pinot lives in the world of real-time and external. So you're building solutions based on the data that arrive in the real time, but also you ship this as application features. You're not shipping them as a PDFs. You ship them in the form of dashboards, API calls, or what have you. So there's multiple different tools that solve in the similar space. The ClickHouse, Apache Druid, and Rockset. There's a few of those in the world of real-time data and data that will be used to demonstrate this to external users. I need to press it. Yes. I'll skip that and I'll talk about this at the end, but you can take a picture right now. So, how many of you use LinkedIn? How many of you use LinkedIn today? Probably many of you, but a couple years back, this answer to this question would be drastically different. So right now, I see many people raise your hands and you said that you use the LinkedIn. Back in the day, it was a tool where you put your resume and maybe return to this like once a year to update your resume and stuff like that. So the people on LinkedIn thought that, okay, how we can increase engagement in our platform? How about we provide some sort of insights? Because we're already collecting this information. When someone clicks on your profile, there will be an event that we placed in the Kafka topic. And what about if we will provide this dashboard for the user so that everybody knows who clicked their profile or saw their profile? You can ask me, like, Victor, why it is important? I'll give you an example. Friend of mine, he did an interview in that company. And after the interview, he actually went to this dashboard and he saw that few people in the company that he was interviewed in were interesting to look at his profile. So he can make some sort of assumptions that he did very well and that he actually might get a chance to get a job in this company. So he can use this today, immediately after his interview was finished. So will this information be useful for him months after that? I don't know. Depends on what kind of decision he's trying to make. But this information happened in real time, and it's good that he will be able to see this information in the real time. And this information on this dashboard is also by nature is analytical, because there might be multiple dimensions. This can be dimensions in terms of when it happened, what type of the level of this person, if it's like a C-level person or like individual contributors or maybe VP level. So he would be interested to learn about what kind of people are actually looking for their profile. And there is a multiple enormous amount of requests, enormous amount of clicks happens. And this information needs to be freshed in a matter of minutes. That would be ideal. Another example of this type of use case is that when someone posted this information saying, hey, I'm starting a new job, or I wrote a new article, I wrote something about this, and your the newsfeed will be also created by running this analytical query against Apache Pinot. I'll try to, in the real life, this query might look much more complex, I believe, but I try to kind of like be inventive about how this query would look like. But it would be complex, but not that complex. So essentially, that's the idea of having this ability to implement new features in the system with existing data and expose this information to users. So what kind of characteristics we're looking here? So first of all, freshness. We want to have data that are really very fresh, matter of minutes, seconds. Second one is high concurrency. Multiple users would like to see this data. Multiple users, many people go into LinkedIn, and this query needs to be executed against multiple simultaneous requests. And also, we should be able to have a parse through a large amount of data. Like I said, it's 700 million users in LinkedIn. Different people might have a different number of the people they care and follow, and who will be responsible for to generate this. Another example would be that example that I was trying to re-implement in the demo that you will be able to see is Uber Restaurant Manager. So Uber, it is a company that can have multiple different types of customers. One of the customer is me as a user. I want to have a burger. So I went to Uber Eats, find the burger, and for me as a user, what I care about, delivery time, what is around me, and how fast this burger will come to my place. From other side, Uber also have customers who are connected to their platform, restaurant managers. They want to see what's the demand, how many burgers were sold, and this information, we ideally want to have it in real time. Because surge happened, we want to see that, ETA time in real time. If the restaurant is backed up and I cannot get my burger in 20 minutes, I should probably choose something else. So I don't care if there would be batch job running, and this batch job will generate some very accurate information in a matter of seconds, but it would be next day. I want to get this data. I want to see when my burger arrived in the real time. So we built this pretty cool dashboard where we have there's a link where you can get this dashboard. Everything is kind of like a local. There's no cloud there. You can play around this, but essentially all the orders arrive in the real time through Kafka. We use Kafka streams in order to do the joins of these orders, because we have some sort of catalog of the products, and we need to enrich our orders information with the information from that catalog. And after that, run some sort of queries that will feed into this dashboard. So, like, if we want to see how much orders we delivered, or what's our revenue and how our revenue would be growing, so we will show this information in the real time. As soon as a new order will arrive, all these things will be recalculated and the dashboards will be refreshed. So quickly about the Pinot architecture. So technically, Pinot is a column-based database, meaning that when we have a record that looks like this, say it's a click stream. We have everything that's happening, one event, and user clicking on the website, we're collecting this data. Pinot stores this in a format that will take these values and serialize them in one chunk and put this in one column. Because of this, Pinot will be able to very fast execute analytical queries, aggregations, summing, and grouping, and all this kind of stuff. Pinot stores data in table, but in the modern system, table it's kind of like it's a concept, it's abstraction, because technically all the data stored inside the things called segments. Segments is the unit of storage inside the Pinot, and the segments can be spread across multiple. The segment would look something like this. So we'll take all the IP addresses, all user IDs, or all times if we need to put different indexes. For example, we want to do range queries against the different time frames. So we put the index for range, and we store this inside the segment. Multiple segments. The data depends on the size of the data, will be spread across the segments, and the segments will store inside servers. It's a very clever name. We come up with this ourselves. I think it's brilliant. I think it's a great idea to call those servers, right? Makes sense. Tough crowd. Okay. So Pinot come from LinkedIn. LinkedIn is a web scale. Obviously, Pinot is not running only one machine. It's a highly scalable system, distributed systems. So your segments not limited by one machine. Those segments would be spread across multiple different servers. And also, as you can see in this diagram, a replication is also a thing that exists there. So if one of the servers will go down, the other server will continue to serve the data from other instances. Servers perform storage. They are keeping the segments intact. They do processing of the queries, and they can be saved. The segments can be saved in the thing what we call the deep store. Essentially, any type of object storage like S3, Azure Blob Store, you will be able to push those segments in case of you need to have some sort of disaster recovery situation when you need to restart the service and rehydrate the data back. Broker, it is a component that will be responsible for serving queries from applications, from any type of clients. So every time when someone writes the query, select from something, broker knows about topology, it knows which server has particular segments, and the broker will direct those queries inside in the server. So server will perform the query and the return result back into the broker. We use this component called Zookeeper that is responsible for storing metadata. Now you can see how the things are getting more and more complex. So that's why we at the StarTree, we start building a managed solution. So when you need to build this type of thing, you just go and use database in the cloud and don't worry about the overall architecture. But it's important to know. So controller is responsible for configuration tables every time when we need to create new job to upload the data or maybe reading data from some streaming solution. The controller will be responsible for taking care of this metadata. Next thing is the analytical data that is used. The page data is nothing new. But how about the data that arrives through the real-time source, like a Kafka, Kinesis, Pulsar, something like that? So the Pinot has native integration with this type of solution. So batch ingestion, every time when we ingest into Pinot, we call them offline tables. This is where I'm not very proud about this name because it's a little bit confusing. It is actually not offline. So it is, available for query immediately, but the name suggests that it's not going to be updating in the real time, meaning that if you need to re-upload this data, you will go ahead and run this job again to read this data from S3, from any file system, etc. With real-time injection, surprise, surprise, we have another name called real-time table. So this table will support constant update of this data. When this data will arrive into Kafka, Pinot will listen the Kafka partitions and store them inside memory and make those segments available for query immediately. So I was asked the question in Slack channel for our open source solution. People asking how fast data will be available after it will arrive into Kafka. It will be available immediately for querying. Think about this like how you can effectively query a stream of data. That would be a great solution to do this. Kafka, Pulsar, Kinesis is kind of things that are available out of the box, but if you have different use case, what can be done? It can be done through the combination, either through Kafka or some other sources that will support like a batch ingestion. All right, so I mentioned Slack. This is a place where people asking questions when they start learning about the Pinot. There's two Slacks, one about open source Apache Pinot, open source contributors hanging out there, people from Uber, LinkedIn, bunch of people from all over the place. They're asking the question and they're working on the open source solution. That's the cool part. And we also have a Slack for solutions that we built at the StarTree Cloud, and etc. Real-time Analytics Summit. I have one more minute to talk about this. We're trying to create a place where we can bring like-minded people who care about real-time analytics, who care about user-facing analytics. It's not only about StarTree, it's not only about kind of like Apache Pinot. There would be the vendors who support this type of use cases from other companies. It is happening this May in San Jose. I was able to get 35% off if you will use my code. I personally will be running full day of training. It's going to be on the May 7th, training about how to build solution based on Apache Pinot, Apache Kafka, and Apache Flink. So your Apache Kafka would be your streaming solution, Flink would be stream processing solution, and the Pinot real-time analytics solution. So that's it.